In this lesson, I'm going to talk mainly about the two processes used to bend wood. Just to start off, have a little think to yourself. What keyword from lesson 1 describes a material that can be easily bent or shaped? That might be something that is malleable. Okay, it's really important that we try and use those keywords as much as we can. Also, what do you think would happen if you tried to bend a piece of wood? And we'll discuss that shortly. Our aims today: understand the two main methods are used to bend wood materials, to recognize which method of bending is used in a variety of products, to describe the process that's needed for the two methods of bending wood, and also to design two products that incorporate wood that has been bent. So how do we make materials more malleable? So if you were to try and I'm going to discuss two ways to do this. If you were to try and bend materials like polymers and metals, you can usually heat them to make them more malleable. So you heat up a piece of steel in a forge, and then you could hammer it and it would bend because it's more malleable when you heat it. You could also do the same with polymers. Polymers tend to you tend to be able to heat them and mold them and bend them in that way. However, because woods are formed the way they are and they're on an organic material, you can't actually do that because obviously when you heat up wood it just tends to char, burn and set on fire. So think about the following points to work out actually how we would create more flexibility and more malleability within our piece of wood. So what would happen if I tried to bend a piece of timber? And you can see the picture on the right hand side, it tends to just split, splinter and break in half. That's even if you're strong enough, because it's actually quite a strong material. However, if you were to hang off a tree branch, it doesn't break straight away. Quite often it can take the weight of your body, and if it's a slightly thinner branch, it doesn't break straight away. It tends to bend. Now you need to think about the difference between what is a piece of timber that we would buy from a shop to make something from, and what actually the difference is between that and also just a tree that is alive in the ground. And discussed in the last lesson about timbers and how you turn trees into usable timber is the moisture has been removed from a living tree, so there's quite a lot of moisture within that, and that moisture makes that flexible. So with that being said, our first method of is where we do something called steam bending, and that requires us to put moisture back into our wood. This is mainly done with like solid timber and not manufactured boards. And you can see there are a couple of products here that show you what they're used for. So the product at the top is the sides of a guitar. You can also use it for making violins, anything that's kind of shaped in that way. And this chair at the bottom is a very famous design of chair, and that uses steam bent ash. These missing words we'll go through later. That's part of the task you're going to have to do. We're going to talk about the process now. So if you were to watch the video, the YouTube video, which isn't mine, there's no commentary over it, so I usually talk over the top of it. But if you have a look at what's being said here, so this first picture at the top, that timber is being removed from a steam chamber, and what that does is steam is more effective at penetrating the grain of the wood than if you just soak it in water, because obviously the molecules of that steam are smaller than the molecules in water itself. So that helps it to absorb that moisture. So that's left in there in that chamber full of steam for about 2.5 hours. Then what happens is the timber is then positioned on a kind of mold, which we call a jig in this particular process. In this example, that jig has got this has got a strip of metal across it to stop it from splintering, which you can see if you watch the video properly, and then it's clamped into place, and then it is it's bent. Now that obviously can bend because that moisture has allowed that to be more malleable. It's still not particularly easy. You can see in the video that actually 2 people are required to bend the 25mm thick ash, and then it's clamped in place as it goes, and then it's left to dry. Now as that dries and the moisture leaves that wood again, its malleability will then decrease again, and it will hold its new shape because it can't bend back into its original shape, which it would want to be in. And that's how steam bending works. Talking more about now how we can make materials more malleable. Just as an example, paper and card are made from the same material, so dried out wood pulp. So wood is chopped up, it's mixed, it's heated, basically made into a porridge, and then all the moisture is removed, and after that, it's then pressed into paper or card. Now, they're made from the same material in the same way. So why is card harder to bend and form, and so therefore less malleable than paper? And the reason is because it is thinner. So if we try and make our wood thinner, then that will theoretically make it more flexible. So that brings us on to our second method, which is laminating. So laminating is when you take really thin layers of plywood. So we discussed plywood in the previous lesson, and plywood is basically when a tree is peeled and it comes up in very long strips, but they're very thin. So what you can do with that thin plywood is you can then use that and bend it and layer it up to make that wood thicker again, but because it's flexible, you can actually make that bend around formers and jigs. So if you were to watch this video, you'd see them doing it. This one, so you take your sheets of plywood and then you can put glue all over the surface. This particular example uses a glue spreader, and that allows them to spread it over large surfaces quite quickly. That has to be completely everywhere. There needs to be no gaps or any voids in that glue. Otherwise it won't actually stick the piece together, especially if you're trimming it and cutting it down. You place all the extra layers of plywood on top, and then once you've done that, you can then put it inside on top of your jig former, and then once you've done that, you can then clamp it into place. So you can clamp it in place with clamps or straps, quite often using a two-part mold. So you have the bottom half, which you can see in the picture there, and you would often have a top half, which is the same shape that you put on top and clamp into place with the wood between it. In this example, we're using a vacuum press bag, which is basically a big plastic bag where all the air is sucked out, and then that air then forces that plywood to go against the actual jig. So the vacuum bag is sealed tightly, and so the air can be removed, and care is taken over positioning the wood on the jig so it doesn't move or change position anywhere. The air is then removed, and you have to be really careful about how you position your hands, and obviously you need to make sure nothing gets trapped underneath it. Then it's left for 24 hours to dry. The vacuum is often left on during that time period in case any of the air leaks back into the actual bag itself. And then once it's done, you can remove it, and then it is stiff, it is fixed into shape, and quite often it can take a lot more pressure and a lot more weight than the original plywood itself. So it can be used in things like chairs and anything that might need to take a greater weight. So often with this process is the edges aren't always straight. So they often need trimming and sanding to make sure they're nice and even. And that happens because each layer, as the circumference of the mold gets larger, as each layer goes on, that circumference gets longer. So therefore, you would need to compensate by making each layer that goes on top longer still. Now, most people don't do that; they just trim it off at the end. But that can be worked out perfectly and done in the correct way. So a good idea of doing this is we need to identify how a product may have been created. Steam bending is usually done in sections that are no wider than 150 millimeters, so it tends to be not thin pieces, but pieces that aren't very wide. Whereas laminating is often done in large widths, so you'll see the chairs in on the mezzanine in the hall are made using laminating. You can often see the striped edges of the laminating as well. So it's a bit of a skill to be able to spot which one's been used and how effective it is. And it's also important to understand bending wood isn't the same as just cutting a curved shape out of a flat piece of wood. And sometimes you can see the difference between those as well. So our task will revolve around this, and we'll be doing some designing as well. Okay, thanks.